All right, hi everybody. I'm Ethan. We're gonna build an event store tonight in Node and answer the questions why Kafka and RabbitMQ aren't good for event sourcing. By show of hands, how many of you know what event sourcing is?
I might.
Okay.
Like Redis?
Redux has some similarities to it for sure. So if you start doing event sourcing, there will be some familiarity there.
Like MobX or something similar.
Yeah, I'm not familiar with MobX, but it's kind of like Redux, right?
It's easier than Redux.
Okay. Right on. Okay. Well, that's good because I got a few intro slides on what it is and why it would be good to care about it. But who am I? I'm Ethan. That's my email address. I work for Quali now. Been there about a month. That's pretty cool. But still, I don't shut up about event sourcing and microservices. I'm really into that stuff. If you want to know more about it, there's this URL. I write about it from time to time. So let's jump in. What is an event store? Well, how many of you write web apps for a living? Good number. Okay, so here's kind of a traditional setup, right? Here's our users. They're happy because we do a good job. And here's a web server. This whole box is your app. You have some business logic and a database with a table. This slide I took from a presentation where I was talking about this silly app where you could create buttons and then people could click them and it would count how many times they were clicked. And so if a user created a new button, you might get a request that comes in to create a new button. And this is Node and an Express thing, so we've got a request body object that has the name of the button that was created. And so kind of the way we would normally treat this is we would extract from this request the information that we care about, feed it into the business logic. Whoops, that went way too fast. Ouch. Here we go. Feed that into the business logic, right? Extracting the name. This is not going to work, that's unfortunate. And so we would then insert into the database a record of having created this button and discard the request that came into us. It's now gone because we have the state that we care about. And then we render a response to the user. Then people are going to start clicking on it. And so we get a post to click the button, feed it into the business logic. We update the click count there because that's what this stellar app does, and so on and so forth. But, what was that? Yeah, it would be handled. It's a simplistic model here. But, so there's some implications though. I mean, that's probably a pretty familiar way of structuring a web app and building one. At any point in time, the database is the current snapshot of our app state. Like, how many buttons have been created right now? How many times have they been clicked right now? And so, skipping one point here, that means that we've lost the entire history. It's gone. What if you had made a bug as you've been collecting all these button clicks? Maybe you were counting 2 for some clicks instead of just 1. How are you going to fix that? I don't know. And it's so severe, that's why there's the 1 there too, because, right? Anyway, you're reading and writing from the same data model. So when you write to your database, it's the exact same model as when you read from it, it's the same as when you write. Some models are better for writing than others. Like a relational database is better at one than the other. So you're kind of forcing yourself to use something, this one thing for everything, even though it's not good at everything. You're not letting it be good at what it's good at. And then, also, we only store what we thought we needed to store. So how many of you have ever worked at a startup before? Okay, was reporting a big deal at your startup? What do you do when suddenly a different reporting requirement comes down the pipe and you're like, oh, sorry, we haven't been collecting the data for that? You're kind of hosed, right? You can start collecting it, but your report can't go back to the beginning of time. So, I mean, the plus is it's really fast to get going with this. If you've worked with Rails, like you can have a blog up and going in 15 minutes. That's pretty cool. But it comes with some drawbacks too. So event sourcing is going to say, hey, let's do this a little bit differently. Here's our web server again with the business logic. And the same flow, a button is going to be added to the system. And instead of taking that request and extracting the information from it and just writing that to some table somewhere, we're going to actually store a record of the thing that happened. So instead of storing the result of the thing, we're going to store the thing itself, the transition here. Okay. Is that clear? Does that make sense so far? Okay, so when those clicks come in, we have some other events that come in that we're incrementing the count of those buttons. And the data that we've actually stored in the system is that sequence of things rather than a table with a row and a count column. Does that feel a little bit weird?
It'd be excessive data. Yeah, how's the size?
Not too bad. It depends on the application. But we'll get into some more of that as we get into building one of these. And the trick, though, is that under the hood, this is exactly what a relational database is doing. So it doesn't just store the current record of things. It stores a log of everything that has happened. And that's one of the ways it maintains consistency. From what I understand, Redis does the same thing under the hood. Git does this. Right? What's a Git repository? It's a starting point and then a series of changes that bring you to your current working tree. Same idea. Any other questions before we go on? Let's see here. So how would you store these events? Well, boom, that's what an event store is for. You store them in something called that, an event store. There are some projects out there already for that. Greg Young, if you've ever been in the domain-driven design world or event sourcing world, his name will come up a lot, and he's led this project called Event Store. This one is enterprise class, it has clustering, it's a really great project, and obviously not one that we could build in one session tonight. So we're going to build a much simpler one that is not enterprise grade. And basically it works kind of like this, what we're going to do. At the heart of it, we have a Postgres database. We're going to do a really thin layer of our own code on top of it, and collectively that is an event store. It's literally going to be one table, and we essentially have to write two functions to make this work in an application. So why would you care about event sourcing in the first place? We talked about the history aspects of it. You can maintain the history of how everything came to be. If you need to generate new reporting and you have the full history, that's easy. Just generate a different way to interpret the events that you have. If you're into microservices development, this would let you get different systems talking to each other, but without being coupled to each other in time. If you can imagine a system where you have various components and they're making HTTP calls to each other, what happens if one of those is down? What happens to the rest of the system? Exactly, it's also down because it's coupled to and dependent on the other component. When you're doing events like this, you just publish events of things that have happened, and then the components are truly isolated. So that's a really good application of this. One really great thing that comes out of that is, how many of you have built background jobs into an app that you've done before? Yeah, so background jobs are like an anemic version of event sourcing, because if you just have this sequence of events, like let's go back here and pretend that instead of button added, count incremented, etc., this was like video uploaded, and you need to transcode that into different formats. You wouldn't want to do that in a request response cycle, so you might kick that off to a background job thing. But if you just got an event stream, you already have all the tooling you need to run a background job. You just have something that observes events, transcodes them, and writes a new one that's like, oh, hey, it's transcoded, all done. All for free, with no additional tooling or work. You have a built-in audit log. Have you ever added auditing to an app? It always seems kind of hacky to me when I've done that, but if I've got a record of every change, and my events also store who did the thing, built-in audit log, no extra effort. So this is unreliable. Anyway, those are kind of the why you would care about it. And so to be an event store, a thing only needs to support two operations. We need to be able to write events to streams, and we need to be able to retrieve all the messages for a particular stream. Now here's a real key thing about the events. They are immutable. Once an event is written, it can never be changed, ever. If it was wrong, you have to write an event that counteracts what was done before. If you've ever done financial stuff and your bank issues an incorrect transaction, they don't just delete the transaction or edit it. They issue a new one to compensate for the wrong one, and then they do another one that is corrected. And the streams are also append only. You can only add new events to them. You never, ever change what has come before. Otherwise, you wouldn't have a reliable history. And so, events are emitted to streams. You can think of streams as just groups of events related to the same thing. A stream could resolve to a user. So like if I'm user 1, 2, 3, 4, 5 in the system, my first event might be that I registered, maybe I moved, so now I have a new address. So they're all grouped together like that. And so an app using an event store will think of things in terms of streams like that. If you've used Kafka or RabbitMQ, a stream is kind of like a topic or a channel, but not quite the same thing. The trouble is that in Kafka and RabbitMQ, your streams and channels, you need to know what those are beforehand. So you kind of define them before you even start running the system. But in an event source application, double clicked, if I'm doing a stream per user, I would kind of need to know who all of my users are before I turn the thing on. And that's kind of impossible unless I make a stream for every person on the planet and hope no one ever gets born. But that's why Kafka and RabbitMQ won't work great, because you can't really make them dynamically. Any questions about that? Is this making sense so far? Okay. This is a quote from Greg Young, I think. It's at least on the Event Store blog, where this is talking about their project in particular, but it's built with an expectation that you will have many millions of streams. And so, yep. So let's jump into some code, shall we? Live coding is always fun. And hopefully this will go okay. So first thing, I don't like to deal with, hang on a second, there we go. Yeah, I'm just going to, I have a simple Docker configuration here to start up a blank Postgres database. And is that legible? Can everyone see that okay? Okay, fantastic. So what are we looking at here? First thing, let's go to Kinesis migration file. If you've played with Kinesis or saw my presentation on it a couple months ago, basically what we're doing here is we're just creating the table that we're going to store the events in. And so this is just Kinesis' way of defining the table's name and then the columns that go into it. So this first line just sets up an auto-incrementing integer primary key. And then events are going to have a type. So if you recall from the one slide with the buttons, there was like a button added type event, there was a count incremented type event. Those would go there. Stream type and stream ID, those, let's look at that on the other one, because that will make more sense. If we come back here, so the stream type is the part to the left of the colon, and the stream ID is the part to the right. Usually those would be like UUIDs. They could be generated by clients. They don't have to be done on the server. But that's what those two columns are referring to. Correlation ID we're not going to get into tonight, but that's for debugging. So if I have some user request come in, it will have a unique correlation ID. I can tag any events produced during that request with that correlation ID. So now I can see everything that happened in response to a particular user request. Versioning we won't talk about, but streams have versions so that you can avoid clobbering other people, timestamp when it was emitted. And so that's just the basic structure. It's not super complicated. Oh yeah, and then the payload one, where is it? Hard to see from here, right there. It's just a JSON blob, so the actual payload of an event can be whatever the heck you want it to be, but the storage mechanism doesn't care about it. It will never appear inside of the payload. So let's go ahead and update our database with this. So I'm going to show you what that looks like now. Hopefully if that loaded. EG at in4. This is weird. Why is it not loading? It usually pops up with Chrome. Let me try restarting that and see if that helps. That is a real bummer. Should we try 3? Okay. This should work. Server doesn't listen. Why is that? Maybe this one? Oh, dev machine, that's wrong. Yep. Here we go, let's try this one. Okay, now it's gonna give me all kinds of errors. Man. Okay, well I guess I won't be able to show the database structure of it. That's unfortunate. All we would have seen is a table that has those columns, so not particularly exciting. Don't know why that didn't work. Okay, so as you recall, there are 2 operations we need to support: emitting messages to streams and then fetching messages from a stream. So what we have here on the left side is just a test file. Most of this stuff up top isn't particularly interesting, just requiring things that we need. And then there's a reset function that deletes all the messages out of the database. So I have 2 tests in here. One is for emitting. And so basically all it's doing, we get a stream ID and a stream type, put them together to make a stream, because app code should think in terms of streams, not in how we actually store events. I have a couple of events here that are missing most of the fields, but we don't really need them for this demonstration. So I just have the type on there, but a real event would have a payload, correlation ID, user ID, that kind of stuff. Stick them into an array, and then call the emit function on the event store, passing it the stream, and then the messages that are supposed to be emitted there, and then we check to make sure that they got emitted. So over here is the function where we will actually do that. So the user has given us, not the user, but the developer calls us with a single stream with a colon in it. So we need to split that out. Like so, because an example of one, again, is like users 1, 2, 3, 4, 5. And so we can do that easily by just splitting on a colon. And we're skipping all the error checking and stuff too. Who's worked with relational databases before? Oh, that's good. In the Node world, a lot of people have only worked with NoSQL. But the convention is to give column names if there's more than one word, underscores. But the rest of JavaScript uses camel case. And we don't want our developers using our event store to have to think about that. So we have to do a little bit of stuff here where we take the messages and then we're going to map over them. And our map function, what it's going to do is return a new object that's made up of what was in the message before. And then we're going to handle the conversion between camel case and whatnot here, rather than making them worry about it. So that was easy enough. And then we just need to write them to the database. So we have a reference up here to our connects connection. So we need to return it. The name of our table was event store messages, if I recall. Yep. And then all we need to do is insert our insertables. And assuming we did this right, yay! So boom, we just emitted events to a stream in an event store. Super complicated, huh? What was that? Too much? Yeah, exactly. Now in a more enterprise grade 1, there are some other things we would do in here, like that version column that we had, we would want to be able to emit streams with an expected version, so that if someone else has changed or emitted things to that same stream before we got ours in. We don't want to clobber each other. We'd want to give a conflict error and let people figure out what to do with that. But at its basic level, this is just it, a way to write events to a stream and get them in there. And if pgadmin were working, we could see it showing these events in the database, but luckily we have the test doing that now. So let's go on to getting events out of a stream. But here's the trick with this. How many of you think it would make a good UI? Because if what we stored, if we want to show a user on the screen, for example, but all we've been storing is a list of transitions that have happened to the user, do you think that would make for a pretty cool user interface? Like when you go to your profile and you just see a log of when you registered and when you moved? Yeah?
I think it'd be cool. Not the only thing, but
yeah. If you're an auditor, that's a pretty sweet interface. But for most people, you'd want to see the current state of things. And so in an MVC application, what we're so used to is what's called a canonical form. A user is a row in a database. That is what it means to be a user entirely. We've pitched all of the history of how it got there, what the actual transitions were. We don't know the intent of any of it or why it's that way. We just have the current state of it. But this leads to a lot of problems. It leads to a lot of coupling at the data layer. So different components of the application all end up writing to this, same column, and it gets confusing. But if we've got a stream of the things that have happened and changed over time, then could we not come up with different shapes for that data? We could. Any component of the system could shape those streams into whatever shape that makes sense for it. And that's really powerful. That's where different reporting requirements come along. So if I have all of these events that have occurred and I need to make a new report, well, that's just taking the events and projecting them into a different shape entirely. And so when we fetch the events from an event store, we're not just grabbing the array of events belonging to a stream. We want to put them into a certain shape. Okay, because the list itself is not particularly useful. Say I need to make a decision. If I have a stream representing a video that's been uploaded, maybe it's been transcoded, maybe some metadata has been added on it. I don't want that list of events. I want a thing currently that I can make decisions about. So let's have a look at what this test is actually doing. We defined a couple of event types. And we're going to have two separate streams here. So that's where stream 1, stream 2 comes in. This is similar to what we did in the last test. We're just building up a stream name in both of these cases. Then we're going to make the actual events themselves. So video 1 being uploaded, video 1 being transcoded, and that's not there. So let's just pretend that wasn't there. And then a similar thing for video 2, it's only been uploaded. So the messages that we're going to emit are, for the first video, it has been uploaded and we did the transcoding on it. For the second video, we've only uploaded it. And so let's jump down here before we look at this real quick. So we're going to set the test up, clear out the database, and put those messages or those events into our event store. And then we're going to do the actual fetch stream. So let's look at its signature real quick. It takes the stream that we want to fetch and something that's called a projection. Who here is familiar with the reduce function? And keeping hands up, who has worked with Redux before? Okay, so a projection is much the same thing. We just get a starting state for a projection and then handle the various types of events we might see. So this particular projection, we just want to know if a video has been transcoded. How would we know if a video has been transcoded?
The extension change.
Not the extension change, because we're not going to look at not the size, but thinking about events that might have been emitted. If we looked at the stream of events for a given video, what would clue us to the fact that this has been transcoded already? Exactly. That's the purpose of this event right here. So we have an event of type video transcoded. Events are always past tense because they're things that have happened. So if a stream contains one of those, then we could know that it has been transcoded. And so if we were going to reduce over the stream to determine that, basically what we need to do is get an initial state for the projection. So if I see no events in an event stream, then this is what the current state of that video would be. If there are no events, I can guarantee that it has not been transcoded. Then I need some functions that handle the event types that I might see, or that I care about actually. I only define a handler for an event that I care about. So if I care about whether or not a video has been transcoded, do I care whether or not it has been watched? Do I care if the user has added some cool metadata to it? If I'm just looking at if it's been transcoded, yeah. So a different projection would absolutely care about those things. One that could show a list of videos to watch to a user. But if I'm just interested in this particular question, then the only event type I care about is the video has been transcoded type. So I need to define a function that takes a current state and this new event and returns what the new one should be. And I didn't do the cool dot thing here, but so all we do is we take the current state and override the has been transcoded event, or I'm sorry, it has been transcoded property on our state. And just for giggles, we'll throw the ID on there too so we know which video we're talking about. So hold on to that thought and we'll actually write the function that does this real quick. So a similar thing, we need to split the stream into its type and ID. And then we need to get the events in question. And to do that, this is a connects query. So we need where the stream type is equal to stream type and where the stream ID is equal to the stream ID. Then we're going to get all of those, and there's a little function I included up here called camel case keys that will make all those camel cases easier to work with. Now that we have all that, everyone close your eyes real quick because I have to cheat because I don't want to mess this one up. Let's see where to go. I'm just going to grab this and not type it all incorrectly. Let's grab this. And so I want to get rid of that. Uh-oh, what's wrong here? Need another one of those. Yay. Okay, so real quick, what we did was we went to the database, we got all of the events pertaining to the stream that the user told us we care about. We're going to camel case the keys so they're nicer to work with. Then we have an array of these events that have been produced there. We're just going to call reduce over them. Our initial state is the init value in the projection. So again, if I see no events and my question is, has this video been transcoded? My initial state is no, it has not been. So I'm going to start my reduction with that. And then my reduce function, like all good reduce functions, takes the current state, the current thing we're iterating over, and will return the updated one. So what I'm going to do is I'm going to look at the projection that I was passed. Sorry, let me make that point here. So this is an object with an object property and then a function property. And when I go to fetch it, I pass in that projection. So I check the projection to see if it has a handler for the current message type or event type that I'm looking at. The first time through this, it's going to see uploaded. That has nothing to do with whether or not it's been transcoded, so I don't have a definition for it. So I'm not going to find one here. So what's my correct state? Well, the same thing as it was before. Just like in Redux, if you get an action that your particular reducer doesn't care about, it just returns the state as it is because there's no change. However, if my projection does define a function for that type, then I'm just going to, the new state will be the result of calling that function with the current state and the message. Does that make sense so far? Yeah.
And this is just me being able to read stuff. On the video transcoding type, are you getting an array of functions there?
Sorry, that's new ES6 syntax. So that lets you define an object property with a variable. So back in the old days, the way that you would have had to do this is with that object declared, you would have had to do something like this, video transcoded equals this function here. But with the new syntax, this is a variable name that's defined up here.
Gotcha. Okay.
So those are equivalent. It's newer syntax, it's a little bit nicer. So I'm going to go ahead and delete that. Any other questions? Okay, here comes the moment of truth. Let us run this test. Yay! So what did we test here? We emitted an uploaded and transcoded event for the first video. We just emitted an uploaded event for the second one. So in our test, we fetch stream 1 using that projection, and we check the result that we get back, and we make sure that it has the correct ID, which it does, and then we make sure that it has actually been transcoded, because that is reflected by the events that we see here. For the second one, similar, but because there is no transcoded event, we expect that to be false, which it is. And then we profit. And that's really it for making a very simple event store. Yeah, Travis.
First, earlier you mentioned that there are immutables you can't change. To change something, you then have to do another
That's right.
event. And so what's to prevent, say that, I guess in this example doesn't work, but what if one of the events changes something, the next event changes it back, and it searches through it, will it not, when it sees that this event happened, because that's what you're looking for, even though another event happened after it, because you didn't look for it, will it give you back false data because
It wouldn't. Let's take that example real quick. That is an excellent question, though. Let's suppose we had some third event that was like, I don't know how you would untranscode a video, but let's pretend that that's a thing. If I were doing my projection, then I would have to have another handler here, untranscoded type, to account for that. So I'd have to return an updated state that would then set that has been transcoded flag back to false. So it's up to me. Any event type that might affect my projection, I have to define a handler for it to tell the system, how does this event affect the state of things? Does that answer your question? There could be a lot of events, and that is actually, in a lot of ways, a very desirable thing. The reason for that is, in a traditional MVC setup, your data contract essentially is all in your database structure. Like, what does it mean to be a user? How do they change? Row in a database. Not very clear. It's hard to look at that and understand, like, what are the rules of interacting with the user? In a system built on event sourcing, before you jump into coding, there's going to be a lot of system analysis of talking with domain experts, people who really understand the thing you're trying to model in software. So if it's a banking app and it's an MVC project, you might just jump in and start coding like, I kind of get how banks work. But with something like this, you need to talk to a banker and be like, what sorts of things do people do with the bank? And you would capture all of those events. And yes, it's some upfront work, and yes, it'll get going slower, but the benefit is that you've traded this sort of implicit database-based data contract for an explicit one. And when you have an explicit contract like that, the components can build to that contract rather than a database structure. And so there will be more typing, there will be events to keep straight, but the result is that the pieces of code don't stumble over each other, and you don't get the kind of coupling that defines a monolith that makes the project hard to work on in the long run. It's an excellent question. I mean, that is an uncomfortable thing at first because we're used to wanting to be efficient, minimize how many bytes we write to a disk somewhere, and this will write more bytes to a disk. There's other implications of doing it this way, like how do you quickly render a UI? Well, I could take these events, I could write them to a particular shape in a relational database, then I could just read that. Well, that's like this whole other extra step I have to do. Now I've also introduced eventual consistency, blah, blah, blah. But the benefit is that the different components remain isolated in their purpose and easy to work on in the long term. Any other questions? Okay, well then we can just, oh yeah.
Reading this is an older technology that's come back and more popular now.
I think so. Before relational databases, from the research I've done, every system was done this way. Then relational databases gave a quick way of just doing the current state thing. If I had to speculate why it's coming back, it's twofold. People are running into the wall with their monolithic applications and looking for better ways to handle it. And two, disk space is cheaper and processors are much faster. So doing this on a 486, that might be a real challenge. But on modern stuff, it's not a big deal because an event store might end up having millions and millions of events. But if you recall, when we fetched, we only fetched for a particular stream. So a particular stream would be a particular user. How many events is a particular user going to have? Not a whole lot. Greg Young talked about an example where they did a loan application system, and the largest number of events they ever saw for a given loan was 100. A computer can shoot through that real fast. Yeah, good question.
So how's the stream IDs, how do they get managed? Are they all unique, right?
They are, they have to be, yeah. So the stream ID part of that combo would roughly correspond to the primary key in a relational database table if you're doing an MVC. And so when I build these, doing a microservices-based system, I usually just have the client generate a GUID for that and ship it up when it's making something new. And so just like that, and you have to do some deduplication checks and whatnot, but a UID duplicating is really unlikely. So whereas I had users 1, 2, 3, 4, 5, and a real system would be like users : 1 B F G dash. I can't come up with the GUID really fast, but
Good, you won't run into the limitation of how many IDs you can have, right?
I assume that's a pretty big number, though.
Yeah.
It just depends on the size of your GUID.
More bits, the more numbers you can have. And that would be an important part of the system analysis. Like, if we're expecting trillions of things, then we need to account for that in what we pick as our identifiers. I mean, I don't know if GUIDs do less or more than trillions. I can't do that math off the top of my head, but just it's part of the system analysis to think about that. Yeah.
So this seems like it would be like really useful for maybe like just like a big user, right? And whereas if you wanted to find out if all of your users they have certain things, would you have a different stream that you also write to?
You could,
That
yes.
like has their IDs as they do a certain event, so that you don't have to cycle through everything checking you already know who's done that event.
Yeah, so the question was, if your stream is for a given user, but you want to do some sort of analysis that goes across users, how would you do that sort of thing? There's a couple of different ways. One is kind of what you described. Event Store actually does that, the Greg Young project. And so you can have a few streams, and in Event Store, you can define, I forget what they call it. I want to say they call it just a projection, overloaded term, sorry about that. But where the system will automatically be able to map from some set of streams and even new ones that get created. So like you could say, I want you to pay attention to all the user streams, and then here's a map function that will write to a new stream based on the ones that have come in. So then now you have a single stream with all the events that you care about. So that's one way. Another way is to do that sort of analysis, and a part of this we didn't get to. So I touched briefly on it, but I can have some component in my system observing these events and then writing them out to some relational database somewhere. Like I might have a users table somewhere, but instead of being created directly from incoming requests, it was generated from me observing these events and writing them in there. And so then I could run that sort of like data warehousing type analysis. But the cool thing is, if I messed up putting them into that relational database, no problem. I've got all the source events. I can just fix the bug and then redo that. So, yeah, another really good question. Any others? Yeah. Pizza.
Pizza's right there.
That is an event. Pizza arrived. So thanks everyone.